So this lesson is on molality. Molality sounds a lot like molarity, but in fact they're quite different, and we have to make sure that we keep them different. I know that I spoke to you about this lowercase m, and now this is where this is going to come into play. So our molarity, which is capital M, is moles per liter, and we should be pretty comfortable with that at this point. Molality is equal to the number of moles, which is nice, that molality, that's where that mole comes from, per kilogram of solvent. This is going to be real important in what's referred to as colligative properties, which is how we're going to actually apply this term molality. So it's not much different than solving for molarity, except that instead of using liters, we're going to use kilograms, and it's not total kilograms, it's kilograms of solvent. Very often that's kilograms of water. Not 100%, but many, many, many times. Water is our solvent that we deal with. So let's try it out. If we have 98 grams of rubidium bromide in 824 grams of water, well, grams isn't very useful, and so I'm going to go ahead up here and do 98.0 grams of RBBR, and we want to get rid of grams of RBBR and use the gram formula weight of 165.37, and we want to convert to 1 mole of RBBR. I put that information into my calculator, and I divide by that 165.37, and I end up with 0.593 moles of RBBR. Molality, which is my lowercase m, is equal to moles per kilogram of solvent. So my moles is easy. That's 0.593 moles. Now, I have grams of water. That's not useful, but if I divide by 1,000, I get 0.824 kilograms. And so my final answer ends up being 0.719. And again, just like I could use the capital M for molarity, I can use the lowercase m for molality. Let's take a look at another one. We have 85.92 grams of tin 2 bromide in 1.40 times 2 grams of water. In this case, I would like you to try to solve this one all on your own and then check your work. Okay, so let's take a look. So, is this what you did? Did you take the 85.2 grams, use the gram formula weight here, and convert it to moles of tin 2 bromide? Then take the molality, which is moles per kilogram, take those moles, and this is 140 grams of water, but I need kilograms, so I divide by 1,000, I get 0.140 kilograms, divide these two numbers, and I get 2.19 molal. And that's how I do my molality calculations.